Hello, in this video I will talk on the basics of the networking, computer networking. In the early networks, there were no interconnecting devices. So there were uh, the machines, and they are connected each other. So of course there are several limitations. The limitations for the total cable length and number of computers that you can connect in this way. So first, let's talk about the medium access control protocols. How does a workstation get its data to LAN medium, that is local area network? A medium access control protocol is the software that allows workstations to take turns at transmitting data. When several machine is transmits, there will be some data collision. So the protocol in this way consider the protocols as the traffic rules that the machines needs to comply. So if no one in transmitting, any workstation can transmit. If there is if someone else is transmitting, so the workstation backs off, waits, and then retransmit again. Contention-based protocols consider that there is a bus. The bus is like a highway that the data travels from machine to another machine, from one workstation to another. When there is a collision, they wait a little bit and then they try again. Network repeaters. The repeater receives a signal generated by network interface card and other devices, strengthen them, and then repeats them to other parts of the network. The traditional repeater has two ports or connections that you can use to extend your network. So basically, they take for example, if you are trying to send data to a long distance, then you use repeater because the data as it travels gets weaker and weaker. So the repeater takes them and then retransmit. A multi-port repeater is just a repeater with multiple ports, and we call them hub. Okay, they receive bit signals generated from a connected computer, and they clean the signal by filtering out the noises, the electrical noises, and regenerates the signal to full strength and transmit the regenerated signal to all other ports. So the hubs does not know which one is which. They just take the signal and clean it, strengthen the signal, and transmit to all others. Okay. So network switches are more smarter than hubs because they learn the machines. So a switch actually reads data in the message, determines which port the destination device is connected to, and forward the message to only that port. So let's give an example here. Okay, so let me see if we have. No, we don't. Okay, so imagine that initially the computer A wants to send a message to computer B. Okay, so computer A here, B here. Computer A puts the destination address as the computer B. The message comes to here. Initially, the switching table is empty. The switch receives the message at the port 6, okay, because the switch also looks at the source address. Source address is computer A. It puts that right here, computer A here, and the port address port is 6, okay, but the switch doesn't know where the computer B is. So at this picture, we can see that computer B is connected to port 1. However, switch doesn't know that because computer B is not in the switching table. The switch, because it doesn't know where the computer B is, it sends the message to all, so it basically broadcasts the data. Broadcasting means it sends to all the ports available. Okay, so computer B receives that. Actually, all of them receives that. Computer C and computer D also receives the message, because the message is not destined for them. They just discard the message. So computer B receives that, and if it replies back to computer A, the message comes from computer B to switch, and the switch looks at the source address. Source is B. It puts that here, B, and then port is 1. Okay, so switch learns another information, and the destination is the computer A, that is the MAC address A, and then it sends it to port 6. So basically switches learns all the locations of the machines, and then it sends more intelligently. Local area network, small network, limited to a single collection, and so on. Okay, and then you see that we have a switch, and that makes it a LAN. Routers. So basically, there is also layers, layer 1, 2, 3, 4, 5 in the TCP/IP level. The layer 2 is so layer 1 is the physical layer. Okay, so the hubs, okay, hubs are layer 1 device. Switches are layer 2 device. That is, the layer 2 has the switches and also MAC addresses, layer 2 address. That is the data link layer, layer 2. Routers are layer 3 layer 3 devices. Layer 3 is the network layer, and at the network layer, which is layer 3, we have IP addresses. So because layer 2 understands MAC addresses, because they are layer 2 devices, switches does not understand the IP address. They don't know about it. Okay, so the routers uses the IP addresses, and routers connects LANs. Okay, so we have one LAN here and the LAN here. Let's look at this image. As computers are added to LAN, the effective communication can suffer because broadcast traffic is forwarded to all members. So in this picture, we can see switches. So these are all switches, and we have some servers in this department, another server in another department. To improve the efficiency for the communication, so this is a better way. So routers create broadcast domains. The scope of devices to which broadcast frames are forwarded is called broadcast domain. Each router interface in a network creates another broadcast domain. So here we have routers, and then we have interface at these routers, and then switches connects all the devices in this broadcast domain, and switches also connected to router. Okay. Routers work with the IP addresses and routing tables. So similar to switching table, routing tables, we have the networks here, and then interface. Okay, so the routers doesn't need to know all the single machines here, but they just know that this is one network, another network, another network, and that is the interface. Okay, routing each node in a WAN, wide array network, is a router that accepts an input packet, examines the destination address, that is the IP address, and forwards to packet on that particular communication line. How does a router decide which line to transmit on. So there are a lot of routing algorithms that is outside the scope of this course, but the router selects the optimal, best path in an optimal manner. Often many possible routes exist between sender and receiver. So consider that between A and G, so there are so many different paths. So it can, the one packet may go from A to D and D to G. Another one is from A to C, C to F, and F to G. So there are so many different paths. Routing versus switches. Routers connect LANs, switches connect computers. Okay, routers work with the IP addresses, switches works with the physical MAC addresses. Routers don't forward broadcast. Switches do, but when we say switches do, if the switching table is empty and before switches learn about the topology, they broadcast. Okay, so routers use routing tables, switches use switching tables. Okay, network of networks. End systems connect to internet via ISP, Internet Service Providers, and of course ISPs must be interconnected. So here, let's say there is a small business wants to visit this web server. The small business connects to ISP, or consider this your home internet. So you pay some subscription fee to an ISP such as Cincinnati Bell or some other companies. So your message comes to here ISP, and then it connects to internet backbone. So there are internet router, and then all the way to destination. Okay, client server architecture. So there are clients. Okay, so they might be using different operating systems, and also there might be some web server. Okay, so web server software communicates with browser software. So no need to write software for network core devices, and because there are some protocols such as FTP, HTTP protocols, and then based on that, you just connect to server. So here, client-server architecture. Server is always on host, and they have permanent IP addresses. Clients communicate with the server, may be intermittently connected, so they don't need to be always on, and they may have dynamic IP addresses, and they don't communicate directly with each other. But in the peer-to-peer architecture, as you can see in the reading material, the clients communicate each other, and when they communicate each other, the clients also act, sometimes they act as a server because they serve to the requests coming from other peers. So the requesting peer becomes client in that case. Okay, so HTTP overview. So imagine that there is a server and this iPhone running a Safari browser and uses a different operating system than this PC, sends a HTTP request and gets a response, a server. Similarly, this PC sends, and it uses a different browser and different operating system. So let's say this is, so this one is, let's say, iOS or the Android. So this might be Windows 10, but the server is totally a different operating system. Let's say Apache web server. HTTP request comes here, and then response goes there. Client server. Okay, so that is the end of the slides. I hope everything is clear, and have a nice day.